Hello, everyone. My name is Theodore. I'm the director of IDEA StatiCa UK, and I would like to welcome you to another Connection Wednesday webinar. Kostis, our support manager, is with us also today, and he's also going to demonstrate the examples we have prepared for you. Kostis, if you can just let me know if you can hear me well.
Hello, Theodore. Good morning, everyone. I can hear you clearly.
All right, perfect. Okay. All right, let's start then. So before we start the presentation, just wanted to mention a couple of things about GoToWebinar. If some of you are not familiar with it, at the right side of the screen you can see a control panel, and you can enter any questions that you might have during the webinar. So we will try to answer them through the chat, but we will also have some time in the end, so just send us anything that you want to ask at any time. Now, during the latest webinars, we have shown several customer projects because we think that it is important to show real-life examples and demonstrate that IDEA StatiCa is not just a powerful software, but it is actually used already in big projects worldwide. In this webinar, we are really happy because we are going to present one of the biggest projects that IDEA StatiCa has been used. And of course, I'm going to talk about it in the next slides. Let's go through the content in this webinar. So in the first part, we're going to present the link with TEKLA. And actually, we're going to show the new link that we have in version 9. And as this was the workflow that was used by our customer. So the connection has been created in TEKLA structures, and then it was imported in IDEA StatiCa for the structural design. And of course, you will see how easy and time-saving this is. In the second part, we are going to present how you can model this connection from scratch. So we will go through this specific connection step by step. So any of you who haven't used the software, you will see how we can do it, and of course how easy it is. But we also want to be a bit practical and provide some useful information to our users and anyone, of course, who is trialing the software at the moment. So for that, in the third part, we are going to present the HelpDesk highlight, which means that a question that we got from a customer that will probably be useful for others to know as well. And as always, just before we finish, we will have some time to answer your questions. So the project that we are presenting today is located in Germany. It was a conversion of an existing kiln line and a new heat exchanger tower that actually was finished just about a month ago, so it went into operation. And it belongs to Heidelberg Cement, which is the largest company in the world in aggregates production and number 2 in cement production. Hofmeier was responsible for the installation and the plant engineering and steel construction of approximately 9,000 tons, so quite a big structure, and the height of this structure was approximately 140 meters. Our customer, SDeng, was a subcontractor for Hofmeier and responsible for the connection design and production drawings. Just a few words about our customer. So SDeng is specializing in detail engineering services using BIM technology. They are, of course, using IDEA StatiCa and TEKLA structures as their main modeling tool. And they're quite powerful users of TEKLA. In 2015, they actually won one of the TEKLA BIM awards for the work in Baku Olympic Stadium in Azerbaijan. So let's start with the first part of the live presentation, which is the new link with TEKLA. And I believe that this also will make a lot of our users happy because we have significantly improved the link, not only, of course, with TEKLA, but with all the software that we link, analysis and tracking software. And just to give you a small overview of how this works and how this has been improved. So with this new workflow, it's much easier to update, let's say, the changes that that needs to be made. So basically what we do is that we create a still connection in TEKLA. Then, of course, we export it to IDEA StatiCa. And there we input all the loads and perform the code check. So we analyze and check the connection. And if the connection is okay, then we just need to create a report and that's it. If it is not okay, and we need to make some changes in the model, then we do these changes in TEKLA model, and we click the update, the new update function that we have, which updates the model in IDEA StatiCa. And then, of course, we have to analyze and check again and see if the connection is okay. The good thing is that you don't have to define again all the loads because everything is kept in the file, and you just need to update your model, and that's it. So let me just switch to TEKLA so I can show you this functionality. So as you can see, this is a part, let's say, of this structure that you saw earlier. And this is the connection that we're going to show today. So let's start with the export. So we have this connection, and we go to IDEA connection tab that we have created, and this is the new link. So we click the link, and this is the new dialog that we have implemented in TEKLA structures. So you can see that you can choose the 3 different design codes that we have available. So in this case, I will just click the Eurocode. And then I need to select the connection point. So my connection point is this one. The next step is to select the connected beams. And in this case, it's this 4 members. Next step is to select the parts of the connection, meaning all the plates, the bolts, welds, and everything. So in this case, I will just rotate the model to make it a bit easier. So I need to select all the individual plates that we have in this connection. There is one here, as also there is one on the other side, and a couple of stiffeners on the main beam. And I think we're okay. So by clicking the the middle mouse button, the software will create, this plugin will create an IDEA StatiCa project. And there we go. So you can see that we have the detailed model, exactly the same geometry, the same cross sections, orientation, bolts, welds, everything that has been defined. We have exactly the same model in IDEA StatiCa. So, of course, we need to define some loads. So I will just add just one set of loads. It's not really important right now. Right, and I'm going to save this project. So suppose now that after the analysis, we see that we need to make some changes in the model, right? So suppose that we need to change this set of bolts. So I can go back to my TEKLA model, and for example, I can double click this set of bolts, and I can define, for example, instead of 30, I can make it 22, just to see the change. So I click modify, and you can see that now the changes have been made in the TEKLA model. So the only thing I need to do is go back to my plugin and click this connection here and update. So what this new dialog does is that it gives me the option to update a model with changes that have been made in the TEKLA model, and I can also have the option to re-input some elements. So that gives me, for example, the option to define some new plates. If I have created some new plates, if I have changed some plates, so I can update them. So now the project has been updated, and you can see that now the bolts has a different diameter. So much easier than it was in the past. So you can see that going back and forth, you can always update your model very easily. And of course, what it is important to know is that you can see here that all the loads have been kept. So you don't need to define all the loads again. Right, so with this, I will switch over to Kostis in order to show you how we can actually do this step by step. So Kostis, you have the screen and the mic.
Okay, Theodore, can you confirm that you can see my screen?
Yes, perfect.
Okay, so I will start from scratch in our brand new version 9, and I will show you how easy it is to model this connection in IDEA StatiCa from scratch. So we'll start from scratch. I will start with a steel grade of S355, a default bolt assembly, and of course, the Eurocode. I will create a new project. And first I will start by orienting some members. I will add the supporting beam, for which I will use a built-up section. I will give it a name, and then set its dimensions. As I enter the dimensions, the preview of the cross-section is changing at the side. I will press OK, and I will start with this beam. I will rename it. I will change its type to continuous. And then I will set the loads to be in equilibrium. I will add another member, which will be the supported beam, rename it, change its geometrical type and direction. I will define its cross section, which again will be a built-up section. Define its geometry. And then I will align the top surface of this beam with the supporting beam. And if I look from the front, we have this result. Next, I will add my diagonals. I will rename it to D1. Change its cross section to circular one. I will rotate it. And of course, remove the eccentricities. Then I will add the other diagonal, rename it. And since this is an exact copy of the previous one, just rotate it around the z-axis. And there it is, the basic orientation of the members. I will start to enter my connection components one by one. First, I will switch to the transparent view because it is more convenient. And first, I will add my gusset where I will be connecting my members. So I'm renaming this operation to gusset. I will define this gusset in relation to the supporting beam, which is member B1. I will use the bottom flange of the beam for defining the gusset. Let's look from front. And then I will define its geometry and thickness. Now that we have defined the geometry of the gusset, I will define its weld, which is a butt weld. And now let's go and connect our diagonals with this gusset. I will use the connecting plate operation, and I will go and connect gusset diagonal D1. I will add this connecting plate at member D1, and I will relate it to the gusset I have just defined. Then I will set the type of the connecting plate to be a tank. I will define the geometry of the tank. I will define its thickness. And then I will move it. Then I will move it along the axis of the member. Last, I will define the welds of this tank to be a double fillet. And as a next step, I will use this tank to define the cover plate. Again, I will add a plate, and this time this plate will be defined in relation to the tank. I will set its thickness and its geometry. then rename it. And then create a copy of this operation, which I will place at the rear of my gusset. Again, let's rename it. Now the next step is to cut the gusset in relation to the diagonal. So I will use a cut operation. And I will cut my gusset by using my diagonal. I will add some offset, and the cut is created. The last step is to add some bolts. So I'm adding a bolt grid. The bolt grid will be connecting 3 plates. The first plate will be the front cover plate. The middle plate will be the tank. And the third one will be the rear cover plate. After we have defined the plates we're going to bolt together, I'm defining my bolt grid. And I will copy this bolt grid, but this time I will replace the tank with my gusset. And again, reposition my bolts. And the connection of the first diagonal is ready. The next step is to copy all these components to the other diagonal. So we'll start from the connecting plate operation. I will copy it and relate it to the second diagonal. Then I will copy the definition of the cover plate. I will rename it. I will choose my plate to be the tank of the second diagonal. And now that I have this already defined, I'm just copying it. Let me rotate the view a little bit. And positioning it at the rear. Let's also rename it. Then I will also copy my bolt operations. Again, I will have to choose the connecting plates. I will use on-screen selection. And now that I have chosen my plates and defined this grid operation, I am copying it again and replacing the tank of the second diagonal with the gusset, and just changing this position. Both my diagonals are connected, and the last thing I have to do is cut the gusset with the second diagonal. So there it is. Next, I will connect beam B2 to the supporting beam. For this, I will use the shifted end plate operation. The connected members are already correctly defined. I will define the thickness of my end plates. I want to fine-tune my end plates, so I'm removing the opportunity to have an automatic height, and I'm choosing to define everything in relation to my profile. So I'm defining the geometry of the end plates. And after they are defined, I have to set my bolts. I will change my bolt to an M30. Then I will define my top layers and my bottom layers in relation to the outline of the member. Okay, there is I have a mistake here. Okay, now that my end plates are defined, I will also add a stiffener with a chamfer of 25 millimeters. And the last step is to define a rib at the supported members web. So I will use my rib operation. The rib will be on member B2, and it will be related to the first end plate, which I will graphically select. The rib will be rectangular and will be positioned at the web of member B2. I will move it at the center and then define its geometry. Last, I have to define the welds. And of course, move the rib a little bit so that it is aligned with the bottom flange of beam B1. The geometry of our model is ready, and the next thing we have to do is load it. In this particular example, I chose to show you one nice feature that is present in IDEA StatiCa, which is the importing of load effects from another connection. So, since I have already modeled, I have this connection already modeled from the original creators, I will copy the loads from the original file. This file contains two project items with the same name. I will select the second one, and the software imports all load effects for all members. Now that my connection is defined and loaded, I can go at the check and solve it. Since this takes some time, I will move on to the already solved model. Now, after the solution is over, we can have a quick overview of our results. At the top left of our window, you can see a summary of our analysis, of the utilizations, and of the backlink check. We have an overview of our model. We can see here that there are no red parts, which means no failures. We have an orange color, which means that these parts are highly stressed, but still passing the checks. We have green colors, which means that these members are optimal. And we have a gray color, which means that these members are over-designed. Of course, at the right side, we have these tabs here, where we can have a better overview of the solution. At the Analysis tab, we can see that all load cases have been successfully solved. Then we have the Plates tab, where we have a list of all the plates present in our project. If I select a certain plate, at the bottom I see a view of this plate. I can always show the von Mises stress distribution in the 3D model and the 2D graphical window below the list. Also, I can see the exact strain distributions, which are important for our method. We also have the Bolts tab. In the Bolts tab, we have a list of all bolts in our project. We can see the utilization and the forces. When I select a bolt in this table, I can see its position in the structure in this graphical window. The bolt is highlighted in black. I can always expand this row and I can see the code calculations. This is the same for the welds, where we have a list of all the welds in our project. If I select one weld, I can see the distribution of stresses on the weld, the position of the weld on the plate it is welded on. And of course, if I expand this row, I can see the calculations required by the code. Last, we have a list of our backlink critical factors, where we can see our backlink shapes. So if I, let's say, select this backup factor, which is quite low and close to the critical one, I can see the deformed backlink shape. And with this, I conclude this part of the presentation, and I will return.
Yeah, thank you, Kostis. I think you can just keep the screen, and so in the next part of the presentation, we have the HelpDesk highlight. So
okay,
I think you can just continue. And,
okay, I will just move on.
Yep.
Okay. So this was the HelpDesk incident that came from a client. This connection is part of a crane runway beam. And what the user was trying to achieve is that he was trying to connect a diagonal to the column and the short cantilever but without success, as you can see at the lower part of the structure. Now, why is that? Obviously, in this structure, only the runway beam M3 and the column C are loaded directly. And for this reason, the members I'm showing you with the orange arrows, members B and M4, they should be modeled as stiffening members. Now let's see why. In our solution, we have two types of members. We have the normal members and the stiffening members. Normal members rotate and move around the fictional node. In normal members, the edge that's farther from the node can be either supported or loaded, and they can also be classified. Their connection can be classified by the use of stiffness analysis. On the other hand, we have the stiffening members, which also rotate and move around the fictional node, but they cannot be supported or loaded, and as such, they cannot be classified by our stiffness analysis. The importance of this limitation is that you can manipulate these members at both ends. So they're a little bit more flexible. And taking this opportunity, I would like to talk about some improvements we have made in version 9. This incident happened in version 8, where the user was allowed to define the member lengths. In version 9, for normal members, we have smart algorithms. As you saw in my presentation, I didn't define any member length. This was automatically calculated. And as a result, if the user was trying to input this connection in version 9, he would have the result you see at the picture in the middle. And he could achieve the result he wanted only with stiffening members. I can show you this in IDEA StatiCa 9. So this is the original file from the client, where you can see that the short cantilever extends from the beam, and also this member here cannot be extended and create the impression that it can be connected at column C. This is not the case with the fixed project item, where we have used stiffening members. And here you can see the difference. The short cantilever does not extend from the runway beam, and also the diagonal is connected on both ends. Let me return back to my PowerPoint. I would also like to show some examples from HelpDesk incidents where we had where the use of stiffening members would provide solutions. So here we see examples of members that are not either loaded or supported, but they are just, let's say, the middleman. Okay, so this is it from my side.
All right, thank you, Kostis. So I think we can have a look at the questions. We have pretty much answered most of them through the chat already. Let me just go through it. Yes, so there is a question that says for the complex sample connection, please show us the reports of the checks which we can submit to the checker engineer. And are there any options for short output and detailed output? So if you can just show us the report functionalities in the.
Okay. Okay, so here at the report, we have we can select first in an IDEA StatiCa project file, we can have more than one types of connections, and here we can select only the current, all project items, or the ones you want to show. Our report is quite flexible, I can say, because we have some predefined things you can show. You can have our theoretical background, the software, info, etc. All these things can be moved around. So let's say that I want the materials before the paragraph. So I'm dragging and dropping it here. I can show certain views from my model. And also, if I go back at my design, I can rotate my model around and take screenshots from the checks or from anything you want. And I can include them here in my model. We have, okay, and the software is recreating the report right now. What you see here is the long version of the report. Let me scroll down a little bit. So here, let's say we're at the table of all the bolts. Actually, this is a short version of the output. We can make it more complex by showing the formulas for each of the bolts, or for the highest utilized bolt. And besides that, we also have a short version, a brief, and a one-page, which is a little bit shorter. And of course, you can export this report in docx or PDF format.
Okay, good. So another question is how to make use most effectively from forces calculated with SIA Engineer to import them to the IDEA software. For example, the complex sample connection was calculated with SIA Engineer. Yes, so basically we have, of course, you have the option, we have a link with SIA Engineer as well. And what you can do is you can export the geometry with all the forces that have been calculated. Of course, we import all the combinations that you have made in SIA Engineer. So you don't need to define any loads. Everything will be automatically imported, and the IDEA StatiCa will calculate the connection based on all these different combinations. So it will give you the worst case scenario. Something else is that it is worth mentioning is that the improvements that we have made in TEKLA structures also have to do with the analysis software. So we also we can also keep all the changes that we have made in the IDEA StatiCa project, and we can re-import changes from the analysis software. So you don't have to define again the model. Everything can be updated very easily. So in the same way that we showed earlier with TEKLA. So I think, of course, we have a lot of material in the resource center. So if you want to see exactly how the import from SIA is done, you can see the step-by-step tutorials that we have. Yes, another question is when it will be possible to export a model S3D to DWG. Now I'm using the cloud option, but I thought it would be also possible through version 9. Yes, it's not at the moment. The only way to export is through the cloud viewer that we have. Yes. Another question. Yes.
Someone was asking for the SIA Engineer link. I think that we already have a webinar where we show this link between SIA Engineer and IDEA StatiCa.
Yes, it's yeah, we have.
It's in our webinar section.
One of the previous webinars. Yes. Okay, let me just check. Okay, can we also have an internal library which we can use when starting a new connection? Yes, of course we can. We also have a library. It's the MPRL library that you can, Kostis, if you can switch to the materials so we can show the button that we have in materials for the library.
Okay.
Yeah, so there it is, the database, so you can use this functionality already. Another question is how, for what kind of material this connection can be calculated. It's still basically, so you only, our analysis model and the whole, let's say, philosophy of the software is to analyze still connections, so you can define, of course, any type of steel. You can change the properties, the grades and everything, but basically it has to do with steel, yes. Okay. Can we also import from SIA to IDEA the non-linear results, the non-linear forces?
I think yes. I think that there is. I'm not sure, but I think that yes.
Mm-hmm. Okay.
I think that
we can check it out and give you a precise answer on that later on. Good. There is some other questions. Yeah, I think we're okay. We're also a little bit over time, so I think we can conclude the webinar here. If you have, of course, any questions, you are more than welcome to send them to us through email, of course. And let me just switch back to my screen. Okay, and so of course, any of you that haven't used the software, I would strongly recommend to download the free trial. So you can go to our website, ideastatica.com, free trial, and we have actually changed the procedure of trial, so you can immediately download the trial, and you can you will immediately receive in your email the activation key that you need. So there is no waiting time. So the moment you download the software, you are ready to go and just open it and use it. And finally, you are of course, more than welcome to join us in the next Connection Wednesday. It's going to be on the 2nd of May, and this will be the last one for this season. So we will join you again by September, October. I'm not really sure yet, but the next Connection Wednesday will be definitely the last one for this season. So, of course, if you want to show in one of the next webinars one of your examples, you can send it to us at the helpdesk@ideastatica.com. So again, thank you very much for joining our Connection Wednesday webinar. Thank you for participating and for all the questions that you send us. And hopefully we'll see you again really soon. Bye-bye.
Bye-bye.